All right, guys, so today we're doing lesson 4-2, where we talk about angle and angle bisectors. Okay, so similar to what we kind of did yesterday, except we're going to learn about the angle addition postulate today, and then talk about angle bisectors. Make sure you have your book, something to write with in your vocab sheet, because of course we have more vocab today. So let's get started. We have a lot to cover. So we are on page 45 here. And our goal today is to use some postulates and some vocab here to find angle measures. So you can measure an angle with a protractor. The number of degrees in an angle is called its measure. So I'm going to have you guys just do question 1 really quick on your own. So they're telling you the angle of measure M or AOB is 50 degrees. So you're going to use that to find the rest of those angle measures. So try B through F really quick on your own, and then I'll go over the answers with you. Okay, so we should have gotten these measurements. So you could have used the protractor, okay, and just looked at kind of what each one was. But hopefully when you were trying to find angles like BOD, okay, you could have used the protractor, or you could have added some of these measures together, okay? So when we're adding angles together, we're using what's called the angle addition postulate, okay? So I'm going to jump to question 5 here, and we're going to go through it. But the postulate, the angle addition postulate, just states that if we have two adjacent angles, meaning those are angles that share a common vertex, okay? But if we have two adjacent angles, we can add their measurements to help find an unknown angle. So if we have two angles, little angles, we can add those together to find the measure of the big angle, okay? So I'm just going to reiterate one more time. Make sure you are drawing pictures with every example we do. It'll make your life a lot easier and a lot easier to understand these problems. So I already have these set up for me, so I'm going to go ahead and do A. So it says P is in the interior of angle X, Y, Z. So let's label this angle X. Remember, Y, anytime the number is in the middle, that's going to be your vertex point. If you remember that from activity 1. So here's our angle XYZ, and they're saying P is in the interior, meaning P is going to be part of this ray that's right here in the middle. Okay? It's kind of a sloppy P. There we go. So let's label our given, and then we'll go ahead and find what we're missing here. So it says the measure of angle XYP is 25. So XYP is 25. And the measure of PYX, PYZ is 50. Okay, so they want us to find the measure of the entire angle, XYZ. Okay, so according to this angle addition postulate, to find the measure of the big angle, I could take these two smaller measurements, add them together, and I get my answer there, a big whopping 75 degrees, 25 plus 50. Okay, so that's how we apply that angle addition postulate. So that is example A. So if we look at example B then, I'm just going to grab another angle for myself. Okay. Let's look at example B. So we have M is an interior of angle RTD. So we got RTD. And they're saying M is in the interior. So M is part of this ray that's in the middle between those R and D. Okay. Labeling my measurements. So we have that the measure of RTM is 40 degrees. Okay, and the measure of RTD, the entire angle, is 65 degrees. So we're going to kind of use kind of a backwards way of the angle addition postulate to find the measure of MTD. So this one's we can kind of do a little mental math with. If my entire angle is 65 and that one angle on the inside is 40, that means we have a leftover 25 degrees for our angle MTD. So that'd be 25. Okay. All right. C, they're going to throw some algebra at you. So I'll help you guys set it up, but then I'm going to have you guys probably solve it. I'm going to pull this out over here for example C, where they said H is in the interior EFG. So we have E, F, and G. And H is in the interior. So here's my picture labeled. So the measure of EFH is, let's see, EFH is 75. And the measure of HFG is 10x. Okay, so they're telling us the measure of the entire angle, EFG, is 20x minus 5. So we're going to use the angle addition postulate here to find x first, and then use that to find the angle of HFG. So go ahead and find x. So set up an equation here. What would x equal? Okay, if you did everything right, you should get that x equals 8. And now we're going to find the angle of, or the measure of angle HFG. So if you did that correct, that would just be 10x. So 10 times 8 is 80 degrees. Okay. All right. So I'm going to, I think we're going to skip D, but you're welcome to come back and try it if you want. I'll put the answers in there for you really quick. But for the sake of time, I'm just going to move on to what an angle bisector is. So if you want to try those problems, those are the answers, but I'm going to move on here. So we have the bisector of an angle is a ray that divides the angle into two congruent adjacent angles. So we have a big angle ABC here. So this line in the middle, this BD, if that is an angle bisector, that means it divides our angle into two congruent, remember congruent means equal, two equal parts. So if this little angle is 30 degrees, then that angle CBD is also 30 degrees. Okay. So we have an angle down here, MAT. So we're going to make maybe a quick diagram over here. MAT. And they said that AH bisects this angle. So we have AH. So that's our angle bisector. So again, if that bisects, that means this angle and this angle have to be congruent or equal to each other. So use that information to solve for A. If the measure of angle MAT is 70 degrees, what does that make MAH? Well, if the entire angle is 70 degrees, then half of that angle would be one bisector. That would be 35 degrees. Okay. Okay. Similarly with B, if the measure of angle HAT, so HAT is 80 degrees, what does that make the entire angle then? Okay. Well, if this is truly an angle bisector, then these have to be equal. So then with our angle addition postulate, 80 plus 80 is 160 degrees. Okay. All right, so let's head over to the last page here where we start to do lots of algebra again. But you can use definitions, postulates, and properties of algebra to determine the measure of an angle. So we're going to kind of put everything together here and use it to solve algebraic expressions. Okay. So I'm going to skip to the try these examples where we have given FL bisects angle AFM. So let's draw an AFM here. AF and then M. And FL, they're saying, is an angle bisector. So automatically, I know already these angles are congruent to each other. They have to be if that's a bisector. So in A, they're telling us we have that LFM is 11x plus 4 And AFL is 12x minus 2. So I'm going to have you guys try this one. It's not too bad. First, solve for x. So if those are congruent angles, what would x equal then in this case? Okay, if you solved everything right, you should get that x is 6. So what would that make LFM? LFM. If you plugged everything in correct, you should get that is a 70-degree angle. And then if we find the AFM, our total angle, the big angle, so 70 plus 70 would give me a measure of 140 degrees. Okay, all right, let's look at B. So I'm going to draw another angle down here of an AFM, just so I can keep all my work together. With my angle bisector of FL. Again, knowing that makes these congruent. Okay, so AFM, so that's the entire angle here, is 6x minus 2. And they're telling you AFL is 4x minus 10. So there's all of our given information. So again, make sure you're drawing pictures with the given. It's going to help you a lot in the long run. Okay. So now let's solve this. So if we have congruent angles here, that means this angle is also 4x minus 10. So a couple ways we can set up our equation. We can just add 4x minus 10 plus 4x minus 10. Or we can also use a 2 as a multiplier, right? It's 2 times 4x minus 10. And set that equal to our entire angle. Okay, so a couple ways to do it. You could just set these added to each other, or you can multiply it by 2. It's the same thing. So we're combining here, knowing that this is a bisector, making these equal. And then we're using the angle addition postulate to set it equal to the entire big angle. So I'm going to go ahead and let you guys solve for x. Tell me what you get. Okay, we should have got that x is 9. So if we plug and chug then to find LFM, LFM would be a total of 26 degrees. Okay. All right, one last thing I want to touch on before I let you guys finish this video is this question 10 from the Check Your Understanding. So we're going to use this diagram right here to the right. So it says in this diagram, the measure of angle 1 is 4x plus 30. So they already drew the diagram for us. That's great. So I'm just going to label it. And they said the measure of angle 3 is 2x plus 48. So measure of angle 3 is 2x plus 48. Okay, so the reason I wanted to go over this question is because this math tip on the right side here, where it talks about vertical angles. So we haven't really dealt too much with vertical angles yet, but the property that vertical angles have is that they have the same angle measure. Okay, so if we needed to figure out how big angle 2 was, okay, that's what this question's asking. How would you explain how to find angle 2? We can use the idea that angle 1 and 3 are vertical angles, so I can go ahead and set those equal to each other. Okay, so if I move the 2x to the left side, that gives me 2x's over here. If I subtract the 30 to the right side, that gives me 18. So I solved that pretty quick, but we should get that x is 9. Okay, and then we have a choice. Okay, if we know we can know angle 1 or angle 3, it shouldn't matter. Okay, but if I plug that in, say to angle 1, we have 4 times 9, that's 36, plus 30 will give me 66 degrees. Okay, so then to find angle 2, what do we know about angle 1 and angle 2? Okay, well, those are supplementary angles, right? So to find the measure of angle 2, we would just take 180 and subtract angle 1. Okay, or we could subtract angle 3 if we knew what that value was. I just found the measure of angle 1. So the measure of angle 2 would have to equal 114 degrees. Okay, So that's kind of using a lot of stuff we did throughout this whole curriculum already. So applying stuff from unit or activities 1 and 2, where we talked about supplementary and complementary angles, and then implying now this angle addition postulates and vertical angles. So I just wanted to go over that one really quick because we haven't dealt too much with vertical angles, but okay. So again, key points here, make sure you're drawing diagrams when you need. Okay, watch your algebra skills. Okay, that could be your downfall sometimes, making little mistakes in the algebra, but making sure you know those definitions. So bisect and angle addition postulate are our big ones from today. All right. All right, so that's the end of activity 4. See you next time.